Hello children, welcome back to our physics class. I hope you're all doing well and ready to learn something new today. Well, so in today's class, let us learn something important and interesting topic of electricity. Well, children, you already know that charges generally either repel or attract each other. But how strong are they? And how the presence of one charge affect the other charge when they are kept at a far away distance. Not only this, we also try to measure how much push or how much pull these charges apply on each other. Okay, so based on that, let us begin our class, today's lecture, that is electricity. First of all, let us start with Coulombs law. So, Coulomb is a scientist. He is the first person who studied the forces acting between two charges when kept at certain distance. So, according to Coulomb's law, he says that if two charges, say Q1 and Q2, are separated by a distance r, then the force of attraction or repulsion between the two charges is governed by the formula that the force of attraction or repulsion between two charges is directly proportional to the product of two charges and inversely proportional to the square of the distance between them. So, according to Coulomb, if Q1 and Q2 are two charges and they are separated by a distance r, then the force of attraction or repulsion between the two charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay, so let us suppose that this is one charge, say Q1, and this is another charge, say Q2. Okay, and the distance between the two charges is given by some r. The distance between the two charges is given by r. So, Coulomb stated that the force of attraction. So, when do the charges attract? When they are unlike charges, opposite charges. One is positive charge, the other is negative charge kept at some distance, they attract each other. Similarly, two positive charges or two negative charges kept at a distance, they exerts repulsion on each other. So, if Q1 and Q2 are the two charges separated by a distance r, then according to Coulomb's law, the force of attraction or repulsion between the two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. All together combining, we can write that the force is proportional to Q1 Q2 upon r square. Force is proportional to Q1 Q2 upon r square. So, this force, after removing proportionality constant, can be replaced with some constant k. So, k times of Q1 Q2 upon r square. And this k is called as a proportionality constant, where k is called proportionality constant. And remember children, the value of k depends on the system of units as well as the medium between the two charges. Maybe the two charges may be kept in some air, the two charges may be kept in vacuum, the two charges may be kept in some material medium. So, depending upon the medium between the two charges, the value of k changes. So, it also depends upon the system of units as well as medium between the two charges. So I hope Coulombs law is clear, children. So according to Coulombs law, the force of attraction or repulsion between two charges is directly proportional to the product of charges and inversely proportional to the square of the distance between them. So writing all together, F proportional to Q1 Q2 by R square, and removing this proportionality symbol, F can be replaced with, proportionality symbol can be replaced with equals to. Hence, whenever equal to is there kept, we have to keep a proportionality constant, and that constant is taken as K, where K is called proportionality constant. Its value always depends on the system of units we have considered as well as the medium between the two charges. Okay, first of all, let us discuss in detail regarding the system of units. Suppose if the value of a force is measured in CGS system, in CGS system, generally we measure force in dynes. Okay, so when force is measured in dyne, then the value of K is taken as 1 by, K is taken as 1. The value of K is taken as 1. So in CGS system, if F is measured in dynes and the value of K is nothing but 1. So as a result, F is equals to 1 times of Q1 Q2 by R square, or simply Q1 Q2 by R square. So in CGS system, the value of F is directly taken as Q1 Q2 by R square. So as this is the value for force, it is measured in dynes. Similarly, suppose if we measure the same force in SI units. So next case is all about SI units. In SI units, we measure the value of F in Newton. The value of F is measured in Newton. N indicates your Newton. So during this time, the value of K takes the value as 1 by 4 pi epsilon naught. So whenever we measure force in Newton, the value of K is taken as 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of free space. Epsilon naught is the permittivity of free space, and the total value, where the value of epsilon naught is equals to 8.85 into 10 power minus 12 Coulomb square per Newton meter square. The value of epsilon naught is taken as 8.85 into 10 power minus 12 Coulomb square per Newton meter square, and its value after simplification 1 upon 4 into pi value is taken as 22 by 7 or 3.14. Epsilon naught is value is taken as 8.85 into 10 power minus 12. So after solving the entire value, you get the result as something like this. You get this result as 9 into 10 power 9. The value of K is taken as 9 into 10 power 9. Okay, children. Units is the value of K is the same as the above. Okay. Newton meter square per Coulomb square. Units for K. Anyhow. So based on these values, this all depends upon the system of units. And already I said that the value of K depends on system of units, because earlier it is only 1, and here as we are considering in SI units, the value of K will be 9 into 10 power 9. Here CGS unit is 1 and SI system it is 9 into 10 power 9. So if the system of units are changing, the value of K changes automatically. Not only this, the value of K also changes with the medium we have considered. Epsilon naught is in the medium. Epsilon naught is permittivity of free space. In the medium, so in free space it is given as something like this. free space, permittivity of free space is epsilon. So similarly, the permittivity of medium, is indicated with the letter epsilon m, whose value can also be taken as epsilon k epsilon naught. Okay. So value of k changes from medium to medium. Value of k changes from medium to medium.